Beh, hola, bon dia. It's a pleasure for us to host Paolo Lucente, or Lucente, no, the creator of pmacct, which is one of the most used softwares for traffic metrics measurement. Actually, it's correlation between the routing and the traffic measurements. Okay. So thank you for being here, and let's enjoy the talk.
Okay, so good morning. I'm Paolo Lucente and the creator of pmacct, and thanks very much to David for inviting me today. And so I'm Italian, so I don't speak Catalan, Spanish, so I'm fair, totally fair to everybody. And I hope you will enjoy this 45 minutes or whatever of Italian English. Okay, agenda. It's nice to have an agenda always. So after, let's get started, right? So you had a course, or you studied traffic matrices for a long time, so now. And speaking about the traffic matrices, is it something useful or not, right? So there are two sides of the coin, right? So it can seem a silly question or stupid question, but actually it is not. Because one side of the coin is that let's say it's still very common that if you go in a network operator, they are, when they speak capacity or things like that, they still upgrade the circuits, because there is a graph and there is a lot of traffic, so it's good that we upgrade. But then why there is traffic over there? So who is generating the traffic? Who is getting the traffic delivered? They don't know. So it's very often the case also that you get there and you upgrade the circuit, and then after that a customer or the source of traffic goes away, and you upgraded the circuit for nothing, right? So it's a non-contextual. They do this non-contextual kind of job. And then let's say the other thing is that it's a topic that it's not very well spoken at conferences, and that's why I knew Frederick and David by name, because in the Spanish network operator technical community, they were the only two making a contribution on traffic matrices in the past few years, I would say 2, 3, 4 years, something like that. And so it's for some reason it's not, they don't speak a lot about that. And then the other part is that let's say the few presentations that are around, typically they stop to the math. Now you are in the university and you must like math, so I can clearly see on your faces. And but in the moment which you get out of the university, math is a polite way to say no to people. So you're not saying no, you just draw some numbers and you are saying no, it's not possible, and things like that. It's something that we will learn very quickly, right, let's say. So so what happens is that, of course, now getting serious, is that they stop to the math in the sense that if you see how many objects at the very end, especially with an external matrix that you can put in a matricial format, of course you say the problem is hardly approachable and things like that. Which, traffic matrices, my experience is that it's a very experimental or very empirical field. So before saying no, you should at least try. We had a very nice discussion with Freddy this morning about being able to test assumptions, to be able to have a test bed, a real test bed where you can do stuff, because otherwise you can invent whatever you want. But then, especially in this field, or in measurements in general, then you don't have the ground truth. You cannot test whether you are doing a good or a bad job. So this is one side of the coin. And the other side of the coin, right? So you can say, so nobody speaks about it. In network operators, there is not a lot of knowledge about traffic matrices. So what you would say is that there is no money behind it, right? Because if there is no money, then there is no interest, typically, I would say. And that is not the case, and that's the funny part of it, right? Because if you speak traffic matrices, those are, a few things that, for example, few common tasks that you can do with a traffic matrix, and all of it, in a way or in another, you can really link it to money, right? And a lot of money, right? So, for example, if you say that I can do with a traffic matrix capacity planning, right? And capacity planning means that you delay, you prevent that you do not buy unnecessary stuff, unnecessary links, fibers, and things like that, right? Or you try to delay that as much as possible, so you push capacity to 80, 90%, and then you upgrade. And then you see whether it's required. You try to determine sources of traffic, all that I was saying before. And so if you really want to attach a money figure to that, I mean, if you even buy fiber in between, a city like London, right, and you see the cost per year of a fiber, it's 10,000 euro per year. So, doing capacity planning, proper capacity planning, you really avoid a lot of costs. So there is really, a need for that. And traffic engineering, it's, another topic that you can link to money, but compared to capacity planning, it's a little bit tricky because, I mean, with capacity planning, you are one hop away from money. So it's like you do not buy a link and then you save money. So it's one hop away. Traffic engineering, it's a little bit more tricky because you can, the purpose is that you can, in steady state, deliver better quality, for example, or when there is a failure, you can engineer the traffic so to get around the failure, right? But if you think about it, I mean, quality, delivering quality, yeah, you can sell quality, but it's a little bit too far. People get nervous when they get too far away from money, then they get nervous. So traffic engineering, it's a little bit a tricky one, but still it's something very useful that you can do with traffic matrices. And then understanding traffic patterns, right? So for example, I don't know, imagine that you are selling traffic. You know how traffic is sold in the internet, right? So at home you have this buffet kind of thing that you pay 10 euro, 20 euro, and then you get all you want. And maybe this buffet that all you can eat will destroy at some stage, not the internet, but it will destroy a few relationships between content providers and providers like Telefonica or whoever has eyeballs. Telefonica is just an example. It is typically sold in megabits, right? So I buy 10 megabits, I buy 20 megabits, 95 percentile kind of thing. And so when you buy it like that, then of course you tell that the price per megabit it's €1, 50 cents, €2, whatever. And of course, if you can understand the traffic patterns of a customer, then the price can be different. So not all the customers have the same price. You can have a better price than your competitor and things like that, right? You can have a customer that does only traffic in Barcelona. And that traffic is might have a different price than another customer that does traffic transatlantic, for example, right? So, another aspect where you can link money to a traffic matrix, for example. And then supporting peering decisions, right? Which is a little bit where we will focus today. And that's another interesting kind of, let's say, subject because I mean, you can have internet only if you interconnect networks, right? So if the peering decisions are the decision or based on which you do or not do an interconnection between two networks, then you see that the importance. So interconnects between networks can only increase because more people have access to the internet, more providers are coming, on the internet and things like that. And if you see the history, I mean, you can imagine that a peering or an interconnect, it's a bridge, right? So the first thing that in history the mankind was doing was tolling the bridges, right? So that you have a bridge, a place where everything should pass. So let's put a price to the bridge, to pass the bridge, right? And so that is a very hot topic also in terms of, money. So having that said, now let's close this techno-economical part, 2 slides, let's say. And so let's have a small review of the traffic matrices, the general models, let's say. So you can have 2 very general model of traffic matrices that are the internal one. And the internal one would be, let's say, pop to pop, so point of presence to point of presence, or aggregation router to aggregation router, or core router to core router. So let's say you have from this to this, or from this to this kind of matrix. And so it's ingress point to egress point, I would say, typically. And then you have the external one, a little bit more trickier than the internal, because the amount of objects that you can put in a matricial format can be quite substantial, quite large, right? And so here you have either, the core router or the aggregation router to the external entity, for example, an autonomous system, or autonomous system to autonomous system. So if you are transiting traffic, if you are in the middle of traffic, so you don't have eyeballs and you don't have content, but you are selling traffic. If you are a broker, there is a lot of brokers, they make good money, I would say. Well, kind of. Let's say then it's very interesting to have this AS to AS kind of traffic matrix. But once that we say that we have these 2 general models, let's say, the general models, it's good for reference, as always, but let's say then maybe the first thing, you all had the programming languages courses, right? They had, you confirm. So the very first programming language that you had, mine was in Turbo Pascal, so I hope you had better luck than me. So let's say the very first course, they tell you about the top-down approach, typically, right? So you should never do bottom-up, so never start doing stuff and then maybe come up with a great idea, but to the top-down approach. So you start with a project, so you start with an idea, a goal, and that, which can be also, you can also do things for fun, but you do for fun with a goal, and then you zoom into the details and you understand how to do that. So let's say that you have, okay, these 2 general models, the internal and external traffic matrix, then let's say you should focus on what you want to do. So let's say you start with a goal. You want to build an external traffic matrix for peering purposes, right? So those could be your, goals. And let's say you might have 2, an analytic part, so see what is happening, and a planning part, so a little bit of forecasting, what could, projections, how things can grow or not grow, and things like that. Or, for example, where I should place the next interconnect, or who should I peer next, right? Because what you can recognize, for example, in this traffic matrix is that, for example, I don't know, you are exchanging, it's maybe actually better in this one, this traffic matrix. So you can, for example, understand that you are exchanging a lot of traffic, for example, with this entity over here, which is not directly connected to you, right? So why exchanging traffic through this entity? It could be very well that you want to exchange traffic directly. Maybe you have a settlement, so somebody is paying some money over here. So better to bypass and get directly to the source or to the destination of the traffic, right? So that is a typical thing that you do, yes, when you want to determine who to peer next, right? and then where to place the next interconnect, right? So it's not very immediate from this kind of visualization, right? But for example, you can have traffic that it's traversing the backbone. So for example, let's imagine you are peering with Google, and Google has their own backbone. You have a network in Europe and in the US. You have customers in Europe, and you are peering with Google in the US. So you are transporting all the traffic from the US to Europe. And that is very inefficient, very not financially viable, right? So what you do is that you do a peering with Google in Europe. Maybe your customers, they are all in Spain, and then you place a peering with Google in Spain, so that you do not travel traffic over the ocean yourself, right? You leave that link available for some other traffic, some parties that are not in Europe, for example, right? So that you don't have to pay the long cable under the ocean yourself. So that is the kind of stuff that you, let's say, that you can do. And yes, so essentially that's, so you start with goals, with things that you might want to do, right? So that's the most important thing. And then after that you start, also trying to visualize your goal, right? So that you have a goal, you try to visualize what you are trying to do. And if we should say that this is the backbone that we are analyzing, I don't know how much you played with the pmacct, and maybe you already hate me for that, for such unusable tool. But if you build an aggregation method like this in pmacct, you end up with something like that. So with a traffic matrix where you know what is the ingress node, what is the egress node, what is the source of traffic, what is the destination of traffic, and then you have a time reference and an amount of traffic, which is the essential components of any traffic matrix, and also of the one that we would like to build to solve our problem. So we are zooming from objectives to visualizing what we are trying to do. So we are progressing in our project. And then we do a shopping cart, right? Because once again, we have our generic models of traffic matrices, but then let's see what we need to build a traffic matrix, our traffic matrix, not a generic one. So we need BGP, and why we need the BGP? Because, for example, we see over here that we have AS path as a primitive on which we want to track in our traffic matrix. So let's say we need a BGP. Let's park for a moment IGP. Let's park because it is an optional component, let's say. But then we need the net flow or S flow, so we need the telemetry. So we need something that tells us how much traffic is passing through our backbone, let's say. We need a collector, for example, pmacct. Storage, so because we want to store things persistently over time, right? So it could be SQL database or NoSQL database. And then maintenance and post-processing, in the sense that post-processing could be visualization. For example, you want to visualize things. And maintenance, because let's say nothing, you should make the thing self-consistent, right? So you cannot, you don't have infinite resources. So at some stage you should delete the data, for example. So I don't know, after 1 year, so you set a retention period for your project, or a rollover. So you decrease the resolution of data, of the data points, so that you roll over, and you say that after, I don't know, 1 month, I have only weekly data, not daily data or 1 hour data or 5 minutes data, which is something that the RRD, for example, does for you, that kind of rollover. You might like or not like it. Raise your hand if you don't like it. And so we are two. And so yeah, that's the thing. Let's go to the optional part of IGP. So IGP, it depends. So for the traffic matrix that we want to build, so for peering purposes, let's say, if you are, don't know, for example, a small organization, then maybe you also need the IGP component, so to do a little bit of capacity planning also of the backbone, right? But if you're in a large organization and you are doing the interconnect, then you are part of a different team than the backbone team. So if you are a different part, then you don't care about the IGP. You don't care about, you know, if there is capacity, if there is not capacity, and things like that. You really focus on these parts over there at the edge of the network, right? So that is why I did mention as optional, and that is also, you know, good for your, you know, brainstorming. So you have a project, you zoom into the details, and you are in the context of an organization, and the organization, you have, you know, task in that organization. Could be wider because it's a smaller organization, or you have a more specific A to B task because it's a large organization, right? And that's in the large organization where you will regret to have got that job, because it will be, you know, 800-pound gorilla project, because the moment in which you will speak BGP, telemetry, database, systems and things like that, you will see how many people of different departments you have to interface in that large organization, especially with IT people and things like that. They are totally not aware of what you are doing, or security people that care about security, and you say, I want BGP, and they say, why? So I hate being asked the questions a lot. So I like that I say I need BGP and they give me BGP, and they ask question why, and and that kind of stuff. So your life can be very miserable sometimes. But let's say that, you know, it's good that you know, you take that in mind. So let's do a step back. So before getting into, let's say, other technical things, let's do a step back. Let's say pmacct, which is the tool that I authored and things like that. So what it can do for you when we speak traffic matrices. So pmacct, it's in the middle, and on one end you have, let's say, data capturing methods. So for example, netflow, sflow, or libpickup. So libpickup is the library where you can mirror traffic off of a switch, for example, and then deliver that to pmacct. On the other side, you have a lot of ways in which you can store things persistently, or not persistently like memory tables, but still it's a storage, and then you can export into some persistent storage, for example. You can also let pmacct not work as a collector, but as a replicator. So you can replicate with the T plugin to third parties, or let it work as a probe. So essentially you get libpickup traffic with pmacct, and you export it with netflow or sflow to collectors, right? And of course, let's say pmacct standing in the middle, it's not just that it takes what is from the network part and it writes it down to the storage, but you can do correlation, for example, BGP ISIS of maps, and then it allows you to do data reduction techniques, for example, aggregation or filtering or splitting and things like that. Why is that? Because you know, networks nowadays, they are generating tons and tons of data. So you know, you need a way to reduce the amount of data, to build customize the data set to, you know, to solve your project, because otherwise you will end up with a lot of useless data. So the moment in which you are in research and development, the moment in which you are in security, you need that. That's the basis of your work. But if you have a project, and if you are in an organization, you are in a commercial environment, then you want a data set that is really fitting your job, your project. So not just a generic data set with which you can do multiple things. And that's why also pmacct, you have all those plugins instances, so you can define multiple plugins instances, and so build multiple views of the traffic. So you collect once and you can build multiple views so that you can solve multiple projects at the same time, I would say. And so why did I start pmacct? So I have 2 slides on history about no, 3 slides, let's say. And I was 23, so it was more or less 10 years ago, and I thought that I found the job of my life. So managing a network. So I thought that you can manage a network like this guy, right? So I said, I found my job. And well, let's say that after less than a year, I understood that it was not really the case. So, but I didn't turn 24 yet. So it was less than a year. I realized that it was not really that was not really the case. So what was my problem in reality? It was that it was 2003. And at that time, there were there were tools, of course, but for example, there was flow tools, very, let's say, very. It was very popular, but that one was giving too much data. There was not a way. There were a way to post-process the data to aggregate, you know, what you were getting from the network, but originally you were storing to disk the whole data set, so every microflows. And if you imagine that in 2003, not all the routers were supporting sampling, so sample the net flow, it was a big mess. So you were really ending up saving every flow of a big network on the disk. And other tools, very popular also at that time, like NTOP, they were also nice, but they were just providing canned reports. So at the very end, NTOP was very useful for a network administrator, right? So I have Office, LAN, and I want to see who is doing what. So I see that that guy is not working, that guy is doing emul and things like that. So it was very useful for that, but I had a backbone. I have regional backbone, regional research backbone, but still I had, you know, to face with thousands of researchers, thousands of boxes, all the boxes with a public IP address, and you could not really filter traffic, so there was not really firewalls. Because you know, I don't know if it's the same over here, but if you have a department and you have a public IP address, if you are managing the network and try to put a firewall in front of it, you have after 5 minutes a professor screaming to you saying, that is my little domain. Why did you put a firewall? Why do I have to ask you to open my box to the world, right? So by doing that, you can imagine infections and DDoS, everything that you can imagine. So you really have a lot of data. You have to do a bit of capacity planning, traffic engineering, and all the rest. And also, NTOP, let's say, was not fitting. So what I really want, so not everything was, you know, invented, right? So I really needed a piece of tool that I didn't really care of the interface because it was just for my own reference and or of the network team, let's say, but that could, you know, compress, aggregate the data on the fly so that I already had a few reports and I could decide every time which kind of reports I wanted to generate because depending on the projects that I had on my plate, so what I was trying to solve in that precise moment. So that kind of flexibility was not there. So that is also maybe a takeaway project, takeaway message for you if you are in your 23, 24 years. I mean, don't assume that everybody has already invented everything for you. So, you know, think out of the box and maybe there is something that you can contribute yourself. And so a little slide to say, I don't want to discuss all the usage scenarios, right? So of pmacct, but just spend a minute on this SDN part, right? So SDN is software-defined networking, right? So that is maybe the hot part where I see that pmacct it's being involved progressively more and more. So imagine that you have a tool where you can correlate, so you measure the network, right? So net flow, BGP, IGP, that kind of stuff. And so the moment in which, let's say, you do that, and so you are able to do capacity planning, so you maybe build also a nice visualization around it, imagine that you wrap it around with the northbound and southbound protocols. So the southbound protocols would be the one facing the network, for example, NetFlow, BGP, and things like that. But the northbound protocol is something by which you can instrument the network back. I don't know, OpenFlow or whatever other protocol that you can think of. Then you have really a SDN controller. So you have really a software-defined networking. So you can program the network back basing on conditions of the network. So that is a hot topic. I mean, by itself, SDN doesn't mean anything, but this is an application. This is really an application. What you can really. So yes, so I have technical facts and non-technical facts. So non-technical facts about pmacct is that I'm very proud of the very first thing because so pmacct, Freddy, means promiscuous mode accounting. So that was the thing. So because of the heritage from only using libpickup, then NetFlow and SFlow, they came at a later stage. So, but it resulted in this name that you cannot pronounce across languages. So it's pmacct, 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 whatever. So everybody pronounces it in a different way. And when you go to technical conferences, at some stage you start drinking with people, right? After, so it's very funny what happens. They cannot really spell anymore. So you are the author of the thing. So it's very fun. So I'm very proud of myself. On the other hand, I cannot do marketing because I did really choose the worst name ever. So that is something that I cannot do. So it's a 10 years project. It's free, open source. You can download it. It's independent. So even when I was employed by, or I am employed by vendors, let's say, it's still independent. So still it's following its own track, its own roadmap and things like that. It's under active development. And there is some innovation being introduced, like the correlation with BGP, the correlation with IGP, and things like that. And now, to be honest, where the innovation is being introduced, let's say, is that on the database part, for example. So for a long time, we had the relational databases, for example, and now there is the non-relational database, the NoSQL. So the NoSQL is a big mess because it's like everybody is going their own way. So there is no standardization anymore. And everybody comes along saying that I have a database. And that is true. I mean, even Facebook now does a database, which I believe it's called Cassandra, something like that, right? So everybody is doing a database these days. Trying to sell it or just to release it to the rest of the world. So what happens is that you should really try to find a way to contain this, because you cannot write a plugin for every database. So with the relational databases, it was easy. You just speak SQL, and then you have the little drivers, and it was relatively easy to develop what you did for MySQL, you do it for Postgre or for SQLite. But then with these other databases, you might end up with different query languages, with totally different ways of query the language. So it's not a small adaptation, it's every time a different work. So let's say now the innovation is in trying to let people choose the database that they want, even whatever, but still contain the work on the pmacct side. So make it scalable in a way, in the amount of databases that you can support. So in that sense, there is, for example, messaging protocols. So nowadays, I mean, what you can do is that you can deliver the statistics from the cache of pmacct after, I don't know, having cached everything for 1, 2 minutes, 5 minutes, and things like that. You write into a messaging, and then on the other end of the messaging, there is the user that they do whatever they want. They use the database that they want. So there is big standardization also behind the messaging protocols and things like that. So this is a little bit, for example, what is going on nowadays in the pmacct project. and then it's well deployed around, we said. And yes, and let's say we had also interesting discussion with Freddy before that I come from the service provider kind of always being in service providers, so service providers as opposed to enterprise meaning, for example, banks and things like that. And so I try to build a tool that is of use to the network operators, to the service providers. I don't really aim to build a tool that is close to the enterprise, firewalls, data center, that kind of stuff, let's say. And technical facts. So let's say there is one or let's say two takeaway points about the technical facts, so the architecture of pmacct, which is that if you remember in that slide, so you have on one side the network capturing methods and on the other storage, let's say. So the first is that takeaway point is that in the middle pmacct has let's say an abstraction layer, because you never want these two different pieces to communicate each other directly, because you never want that, I don't know, if you develop a new database, then you should triplicate the work to do it against libpickup, netflow, or sflow, or the other way around. Every time you develop a new protocol or support a new protocol, then you have to redo the job for every database or backend that you support. So there is an abstraction layer in the middle. So break the traffic matrix in a way, in this sense. So the other part of it is that it's a pluggable, so this is a pluggable architecture. We already said before that you can build some multiple views of the traffic at the same time. And then the other part is that it's multi-process and multi-thread, because nowadays, not in 2003, but nowadays we have multi-core CPUs, right? So by being multi-thread and multi-core, essentially you manage to spread the load of the various components of pmacct over the available core CPU cores. So for example, you have the network facing part, it's always called the core process, and then you can have multiple plugins that where you can aggregate the traffic and write it to a database. So, and those you spread over the available cores. And where you multi-process and where you multi-thread, it really depends how much information on how you should exchange information between these processes or cores. So that's the decision at the very beginning, if something should be implemented as a core, as a process, or as a thread. So as you might know from your computer architecture course, that they all had okay, so I mean, a thread has a much, so two threads have much more exposure to each other compared to two processes, right? So if you, but on the other hand, threads, so the exposure is twofold. So you have the good part that, you can exchange a lot of information very easily. And on the other hand, you have timing issues. And of course, you can very easily corrupt one thread with the other thread, right? So there is pros and cons. So I like segregation a lot. So whenever you can do it multi-process, then you do it multi-process. And that means that you must have a very simple inter-process communication. So if just a pipe or a one-way pipe it's sufficient, then you segregate the process. When you need a lot of interaction, then you do multi-thread. And for example, multi-threads in pmacct, it's the BGP daemon and the NetFlow daemon. They need a lot of interaction. They need to do a lot of correlation between them. And so, yeah, that is a good case for multi-threading, right? So the inter-process communication determines whether it should be two processes or two threads. And so just what I said. So let's say one of the innovations, so this is if we step back a few years in pmacct, and very relevant to traffic matrices is the fact that you have, the BGP daemon into a NetFlow collector. Let's say that was in 2009, 2010. Let's say 2008, 2009 more. Let's say it was not something, that in the open source community there was nobody doing that. There were only commercial vendors doing that, and you would pay a lot of money, and most of them, they were even suffering of scalability problems, let's say. So it was a very fun job to do in that time frame, right? So you would have, the NetFlow thread receives data, you have the BGP thread receives data, and then the moment in which you get a NetFlow from, let's say, a router, you correlate this data with BGP if it is available, right? And the moment in which you do the correlation, then you send it then to the plugin, and it takes care of the, writing it down to the disk. And a few key points by which I implemented the BGP daemon is essentially two things that we can say more, other than it's a thread. One is that the BGP daemon is really a root server. So the BGP is never used to compute all the BGP information to compute a single view, a best path kind of information. But it's a root server, so you keep all the BGP tables separated, and so that then you know every corner of the network what are the best paths, so you never mix them. So you always want to retain the very detailed information in every part of the network. And the other is that it behaves as a passive BGP neighbor and doesn't send any sort of updates and things like that, because of course network operators are very religious to so if they give you BGP, then you should be very sensible to what you do with that. So all the information, all the interaction should always be started from the network, because the moment in which you start trying to, contact the network with your daemon, then, they will detect that, and that's something that people don't really like. BGP in a live network is an essential component, right? So should be very careful in what you do. So why BGP at the collector, right? Because somebody can say, if you studied a little bit of the NetFlow protocol, you know that it's flexible. So you have this kind of TLV approach where you can even define new primitives. And so why, for example, you don't have a field in NetFlow that says about AS path? Why you want to peer with the BGP collector? So the idea I had at that time is that, of course, first of all, a router manufacturer will take a lot of time to develop. Imagine that there is a market request and they do that. It will be years before it's over there as a feature. But most importantly, let's say, so NetFlow should really report about the data plane, so how much traffic is being transported and things like that. But imagine that you start putting a lot of BGP into the NetFlow. It's like you are transferring the control plane over and over. There is a lot of duplication of information over there. You can compress as much as you want, but at the very end, you are duplicating something that BGP does for you very efficiently. So if there is a change in the network, I flag the change. Otherwise, I'm staying silent, right? So that was the original goal. And I never, let's say, it's a question that I got at the very beginning when I did all of this, but then when I gave that answer, it was well accepted, I would say. So that's why it's there. So setting the pitch, so we get back a little bit to our traffic matrices kind of stuff. What we need. So we said that the first part of the recipe was that we need BGP, right? So what we do is that to build our traffic matrix, so let's say we have pmacct as a collector. So we let all the PE devices. So the PE devices are the provider edge devices. If you remember from our slide before, the one where we were visualizing our traffic matrix, they were the yellow balls, let's say, that were at the edge of the network, right? So we let all the PE devices to BGP peer with pmacct, and they will be facing, the peers, the transits, and the customers. So the customers, they are typically buying from you something, so internet, the transit you buy from them, transit, and peers, typically you are exchanging traffic, typically for for free. I was saying for beer because that's you peer for beer. That's usual. You exchange a beer because you set up a connection, and then it's free of charge, and so you just it's a way of saying with peer for beer. So that kind of stuff. So let's say so that's the first thing. So in our original implementation of pmacct, there was a very, let's say, silly approach that was you know, it was taking, let's say, 50 megs per routing table, right? So you should really scale it linearly. I mean, you have, I don't know, 10 routers, it takes 50 megs, then I need half a gig of memory to store all the routing tables. But then, of course, that was not very, very scalable, because I was already facing the problem where I had to connect 100, 150, and in one case, even 500 Ps. So if you start doing the math between 50 megs and 500 Ps, then you already see that you need gigs and gigs of memory. And people, they were not really liking it. So once again, not because it's not efficient, but because it's money, right? Because you need a lot of money, and money costs. So so I had to invent something, and what I did is that I essentially I did a virtualization of the RIB, right? So you have this blue line over here, which essentially means new implementation by which you have only one RIB. And then for every routing entry that you have in this RIB, you have an information saying which router has that route. So the moment in which you are trying to resolve an IP address, you go there, you find a route, and then typically the BGP routing table is consistent across the whole you know, autonomous system that you are observing. So you find that route, and then you see whether that router has that route or not. Typically they will have the route or not have the route, and then you can look up what are the BGP attributes for that specific router. Why is that? Because you can have multiple exit points, and different routers might have different exit points and different BGP attributes for a specific route. So that's what you really want to do. So if you see, it's a virtualization method, and that was driving more or less on the 500 peers, you know, to 17 megs of memory, 17, 18 megs of memory instead of 50. And for 500 peers, it was felt that 9 gig of memory was okay. So, and I agree, I would say. So how do we configure this BGP? So we said that all the P routers, they are you know, BGP peering with pmacct. pmacct would be configured on the P devices. Maybe you already found it if you used that as part of your lab. You should configure it as iBGP, so the internal BGP session, and you configure it as a route reflector client, so that you have all the routes. So also the other internal BGP routes, they are being reflected regardless. Let's say there is no kind of you know, evaluation whether I should or I should not reflect the route. You always do that, and let's say the one nice thing about pmacct, let's correlate two different information I gave you. So the one is that pmacct acts as a passive BGP enabler, so it's always waiting for connections. And so that means that pmacct can always see in the BGP open message, can see what is the AS number that the remote AS is contacting with. So you can always reply with that same AS number. So that it means a single pmacct can act as an iBGP peer also across a big network where you have several ASs or several sub-ASs. So a sub-ASs, it would mean when you have a confederated BGP system. So looks like as one AS to the rest of the world, but inside you have several smaller ASs with typically private numbers, let's say. Private AS numbers. So the BGP next stop should represent the remote edge of the model, because let's say, so you are, let's say it's very important, and I would say that's the typical way in which, it is, at least for MPLS networks, let's say, that's very important, because you will always, and we will see it in the next slide, get net flow where the traffic is ingressing the network. So it's very important that for building a traffic matrix, to know what is the egress point, where the traffic is getting out of the network, right? And of course, you can have several scenarios that, for example, you can have confederations, or you can have, for example, some small routers sometimes that have only partial routing. So they don't have the full table, but only local routes or regional routes, and then they have a default route. So the moment in which you have a default route, of course, you kill the concept of having a BGP next stop, which is the other end, so the egress point of the model. So what you can do with PMCCT is that you can do also multiple lookups. So you can really follow up. So let's say that you understand, PMCCT understands that you are doing a lookup and you are hitting a default route, and then you can go, to which router that is pointed to. You go in that routing table and you see then how that router would route that specific to the destination. So you resolve what is the real egress point. And so the second element that we said, so we said the BGP. The second element that we need to bring to the collector is telemetry, so NetFlow or SFlow. So there are several ways in which you can export, let's say, telemetry to the collector. Some of them are really bad ideas, and you will recognize that bad ideas are very common, especially in networking. And they get market because there is money behind them. Remember, always money. That's what moves the world, unfortunately. But so the recommended really way to do that is ingress at at the ingress point. So let's say at the edge interface, ingress facing, let's say, the P router. So why is, and of course on the interfaces that face peers, transit, and customers. So if we want just to go back a few slides, it would mean essentially you collect a net flow over here, and over here. So you already see that if you collect net flow ingress at all the ingress points, at the very end you end up with a consistent view, right? So the first thing that you do by just doing this is that you prevent duplication of flows, right? Because if you started, for example, also collecting flows on these routers, so the P routers, of course you can end up with a mess. You can be collecting the same flow twice and things like that. So by doing that, you have a consistent view of the traffic, and also you have one big benefit because you are at the closest point to the source of the traffic, not to the source of the traffic. The source of the traffic, it's the source AES. And the source AES, you can always track it back because you have a prefix and you can track it back to the source AES. But the key point is the peer source AES. So who is injecting traffic into your backbone, right? So determining that, it's key in a lot of cases. Wherever you are doing, for example, an external traffic matrix, it's a key point. And you can do that for sure only if you collect the traffic over here, right? Why is that? Because traffic is routed to destination, so you always have all the information what happens from this point onwards, right? But over here, at least you have the input interface, right? And then you know that, for example, to that specific interface, the CY entity is connected. So you can say that CY, for sure, it's injecting traffic into your backbone. So once again, why is that? Because you can say, okay, an idea could be that I know that the traffic is being sourced for this red flow, for example, right, in CZ. So you can say I do a reverse BGP lookup. So I do a BGP lookup from this point to here, and then you say, okay, then I know my stuff. I'm sure of what is happening. But that is wrong, because remember that traffic, it's not guaranteed that flows symmetrically. So for whatever reason, you can be routing the traffic a specific way, but the way in which people route the traffic to you can be different. So the only way in which you can be sure where traffic was coming from, so who is injecting the traffic into you, is to use the input interface. Never do reverse BGP lookups, right? So that's the reason why you should be always as close as possible to where the traffic is entering your network. Right. So, which is essentially what is explained over here, and then of course, the other way, which the other important thing is that it's what I was already saying before. So this is actually a repetition. I mean, in modern network, there is a lot of traffic that is passing through, and so they are generating a lot of data. So at some stage you need data reduction techniques in order to manage the amount of data that you are receiving. So at the router, the typical thing is that you employ sampling. So you have sampled net flow, and let's say at the collector you can do aggregation. You can do aggregation actually also at the router, and that is why I wrote over here, be sure to carry the IP prefixes, because you can aggregate too much, and then the collector cannot do the net flow to BGP resolution anymore. So you can aggregate things, but the prefixes should be there so that you can attach then the BGP attributes to that. And this is not really adding anything to what we just said, but it's a nice workflow in 4 steps. And I like it. There is a lot of colors over here, and let's say that this is the observed, AS. So let's say that you have this workflow in 4 steps. So step number 1, let's say the P routers, right? They send the full BGP tables to pmacct. So that's step number 1. Let's say that we have a step number 2, which is that the traffic flows by. So we have a traffic from a source AS to a destination AS, and we are on the middle, and we have an ingress point and a egress point. The fact that the traffic is passing by, so it's getting, this is our ingress point, right? Elicits the net flow, so triggers the fact that we get a net flow record. So that's step number 3. And then the step number 4, it's that we correlate this. Where is step number 4? Ah, yeah, here. The step number 4 is that we are getting, this is net flow, this is the BGP table, and we do the correlation. So we get the net flow, and we go in the BGP table that we receive from that very same peer router, and we correlate data. If there is, so we do the correlation with the source address of the net flow that's originating the net flow packet with the BGP, so with the source address that generated the BGP one, or we use the BGP router ID, which is a field that you have in the BGP protocol. Based on this, one of these things, we do the correlation. Right. So we had of our shopping cart, we are halfway. So we have we said we do not discuss IGP. I put it in the backup slides. So let's say in the sense that you can have it's for your own reference. When you get back home. Let's say, and then we get, so we have BGP, we have telemetry, and then we store data persistently, right? So also here, I think I already elaborated a lot, so this will be a very quick slide. So you should try to aggregate data when you are writing it down, because you want to be optimal to your resources, because one of the most expensive operation is consolidating the flows. So let's say that you have a very big key, for example, and you want to reduce that key to a smaller key. And that kind of consolidation, especially if you do it on relational databases, it takes a lot of resources. And so we get back to the project-driven thing, so the top-down approach, what we were discussing from the very beginning. So you should build a number of, because it's inexpensive, so you can even build multiple data sets, each one to solve one or multiple of your project in optimal or semi-optimal way, but still, you know, you have a data set where you can build reports very, very quickly. And that's, in my opinion, the most important part. Then disk space, so you build several data sets, that's, you know, okay. If you think about it, disk of, you know, CPU memory disk, it's the less expensive resource in the end. And open source databases, you know, for a long time they appeared as a natural choice for a few reasons, because they can handle large data sets, because of the flexible and standardized query language, which comes back to what I was saying before. So you learn one query language, and then maybe you have just to learn small dialects, so that one database has something and another database doesn't have, it's not fully compliant and things like that. But at the very end, I mean, you are pretty much fine. And also you can leverage, you know, fresh graduates from university to do projects, right? So they don't have to learn everything from the scratch, something that they never saw on a textbook and things like that. And yeah, they are solid and scalable, because you can do clustering or partitioning or both of them and things like that. But like I was saying, the NoSQL databases, they are picking up very, very quickly, and you know, over relational databases. And I wrote between meat and bust because of what I was saying before. So there is a lot of them. All of those, you know, they use different query languages and things like that. Some of them, they, you know, it depends whether they provide you an advantage over relational databases or not. There is not a unique answer. And that is, in my opinion, another very experimental kind of field, right? So where you cannot never say, NoSQL databases, it's better than a relational databases. For sure, it's cool. So, and people like to do cool stuff. But let's say that doesn't necessarily mean that it's the correct way of handling, you know, the problem. And I think, yes, yeah, we are getting there. You are getting to lunch. What time? Right.
It's like 2:05.
Oh, okay. So I just conclude this slide saying that on scalability, I mean, you cannot really, let's say, fit everything on a single collector, and so because you have, let's say, limited resources, so memory, CPU, and things like that. But the divide et impera approach is very valid, so you can really do sort of spreading of PEs over collectors, and then you know, the important thing is that the NetFlow and the BGP from the same PE, they are let's say bound to the same collector, and then you can assign also collector to databases and things like that. So divide et impera, it's very valid. You know, you have a traffic matrix, you have several collectors, each of them, you know, builds a partial traffic matrix, and then you can reconcile to get the full picture, the full traffic matrix later. And also the matrix can get big by itself, so you have several tricks where, for example, you can try to reduce it, at least to in some scenarios, to make, you know, use of just half of the matrix and not all of it, or keep items like routers or small or things that can fall outside your exercise, you keep them out. So then we have the last point, and maybe it's homework, I don't know. Oh, okay, I can just say something. So I did... Yeah, the idea. So I did work in the past for this AS286, which is an internet provider. And so we were saying the whole shopping cart for our traffic matrix, but where our traffic matrix falls into the process of an organization, falls into a continuous cycle where essentially you start with the negotiation of a peering, because you say that I need to connect with, for example, with Google, for example. Then you go to an engineering part where you exchange with the engineers of one company and the engineers, for example, of Google. They exchange information, what we want to exchange over this peering, hot potato routing, cold potato routing, and things like that. You put that in production, and then you go through the optimization part, because you see that some traffic is taking very long routes, for example, or you want to decrease your cost, and then you go that you want to add, for example, a second kind of peering with Google, and things like that. So it's a continuous process. And of course, the optimization part is where the traffic matrix and all we described falls into, so optimization of cost. And let's say also in the engineering part can fall. Let's say production is just monitoring that everything is fine and things like that. And what was the, let's say, the case, you know, so you have some numbers about, you know, what we were monitoring. So 250 gigabits kind of, you know, overall global, you know, traffic, peak traffic, more than 100 routers being monitored. And this was more or less, you know, the architecture. So you have, you know, the routers, you have pmacct, you have MySQL, and you have the internal users that do, for example, SQL queries, and they get it through web or email. For example, every week they get a report. And if you see the collector environment, I mean, it's very, you know, normal stuff. It's common off the shelf. I mean, AS286, they have, you know, some, let's say, preference for Solaris Spark, but I mean, I would do the same if I was in a network architecture, you know, if I was in the university. I mean, it's quite outdated kind of architecture, I would say. I like it personally, but you can do that with a normal PC. And finally, this is really the final slide and things like that, automation. So whatever you do, traffic matrix, pmacct, it's all nice, but then, for example, my boss, the first thing was saying is that, can I automate it, right? Because if I cannot automate it, then, I mean, I don't care about doing a traffic matrix, because who will maintain that? You will go away, and I went away, and then who will, you know, do this for me? Right? So automation. So it's very important that the routers can just be pointed to an IP address when you configure. So you receive from the manufacturer the router, and then you configure, and you can templatize the configuration. And the other part is that you do the documentation. So do always documentation for whatever project you do, which is boring, absolutely boring. I hate doing documentation, but it's very important. And finally, I mean, also maps. Imagine that you have to do some maps to correlate some fields to others. I mean, they should always be built by scripts and things like that. So never manually, or never that there should be never a process of inserting manually items in maps. So everything should be done automatically. And thanks very much. And I did prevent you to do any questions. So all of this delay was on purpose, not to let you ask any questions. And you can do that later by email, or keep in touch via LinkedIn if you're using LinkedIn.